So thanks again for the Professor Lina's demonstration. So now let's back to the left part of this lecture. So now let's start with the piled rafts and the piled cap structures. So now let's consider what is the connection between the piles and the environment on the top of the piles. So we should use the pile rafts and the caps to connect these two different parts. So the pile rafts are the foundation methods for the embankments on the soft subsoils. And also it's a continuous reinforced concrete slab with the pile foundation. But for the pile caps, it's not a continuous slab. It's kind of a thick concrete mat, which is connected on the top of the piles, like this. But unfortunately, the pile cap structure is not often used in Finland now. So the pile raft now is a very common use method in Finland. There are two different types for the pile rafts. The first one is the flat pile raft, shown in this figure. And the top part of the figure is the embankment we have. It's from the cross-section view. And this is a slide for the flat pile raft, which is from the top view. We can see the thickness of this flat pile raft is the same. But for the pile raft, thickened only at the pile connections, shown in this dashed box. So, but between the different boxes, we just use less concrete for the slab. So that's the difference. There are different criteria for the selection of the raft types, such as the masses of the raft, or the shape of the raft, like this. For the flat pile raft, it's easy for the construction, but they use more concrete because the slab looks like this, and it's more expensive. So that's the mass of the raft and the shape of the raft. Also, we should consider the complexity of the bedding works or the reinforcement work. Sometimes we need the foam works, so we should use some mold, especially for this part of the embankment. Also, there's criteria for the differential segment of the piles. So the pile raft is very often used in Finland, and it's often used for the infrastructure such as the railways on the road, on the highways. So it can be suitable for many different conditions, such as the soft subsoil with a thin dry crust. Normally, the thickness of this crust is less than 1 meter. Also, it can be used in the inclined ground surface of the approach embankments of the bridges. For some deep soft soil basins, the pile raft foundation usually more economical. It's cheaper. Also, the pile rafts can be used for the low embankments, the slopes with the gentle angles, or even the preparation for the widening or the low increase situation. But the pile cap structures is not a continuous life, so it's limited for some situations. But it works well for the stiff clay subsoils with a high enough shear strength, so the fill materials can not penetrate to the subsoil, and the subsoil can support the pile cap structures enough. Also, when the strength of the clay is at least 15 kilopascals and at least 1 meter thick dry crust layer, we can choose the pile cap structures. Here we should be careful. The pile cap structures is not suitable for the pin size projects in which there will be some future modifications for the piles. So the pile cap structures can be used some reinforcement textile or net on the top of the protective soil layer when the embankment is less than 3.5 meters. And for the maximum settlement of the reinforcement, it should be used less than 100 millimeters. And for the frost protection, we usually use the design F20. This is a freezing index according to the standard. Here the 20 means 20 years as example. So for the frost, the most critical area is usually in the lower slope of the embankment. So now we have a very easy question. So in a group of piles, what is the most used of the top of the pile to for the bearing used for the infrastructures like roads or railways? It's very easy.
The question isn't clear.
Something wrong? Okay, no, we just show the answer. Of course, it's parallel, because the parallel is the most commonly used in Finland just for the infrastructure. The pile cap is not often used because it's not a continuous concrete slab. So now we show some pictures. This picture is an example for the connection between the pile and the embankment. This is the connection part. And this is the thick part of the slab, so between the piles and the slabs. Here is an example. Is the pile is driven too deep, even underground. So we cannot find the pile above the ground. So for this case, we should add more concrete to this rebar to make the pile longer for use. And this is when we work on site. Sometimes we just do some excavation work. Maybe it's very close to the existing piles, and we'll just damage the existing piles, just like this is damage the piles. So this white color is the geotextile used for the pile rust structure, which is the bottom of the slabs. So now we have brief introduction for the arching phenomenon. For arching, it often happens for the pile cap structure, and it's useful because it can help the piles to release the loads above from the embankments to make the soil more stable. And also it can avoid some big sediment between the piles. But for if we have, this is a pile cap structure, if we replace it with a slab structure, we don't worry about it because for the slab it's a continuous structure slab, so the arching is not critical. So for the arching phenomenon, it's very difficult to explain it in details. But if you are very interested in it, you can search it online using Google Scholar or Wiki to see what's happening for this. Of course, you can do some research for that. The stress distributions caused by soils for the arching just distribute in an arch-like manner. So this is the difference. So the internal shear strength will just resist the movement from the original place, make it more stable. As mentioned, here is the advantages of the arching. So more arching phenomena happen in the coarse grained soils, and it can distribute the earth pressure more evenly into the subsoil with varying capacity, or it can decrease the settlement and increase the stress. So here are some factors affecting or dissolving the arching. For the affecting factors, here's a list, such as the height of the embankment, the friction angle, and the space between the piles and the shape of the pile caps. This will affect the arching. Also, too large differential sediments and dynamic loads, even the heavy rainfall and the repeated freezing will dissolve the
Okay,
arching.
may I add one thing? Maybe you go one slide backwards, or two slides backwards. Okay, I wanted to show this one. This is from the old slides I have. So the idea here is that pile raft is not very so how can I say? In a pile raft, it's relatively expensive way to get this. So instead of using pile hats would be more economical and also more this economic and ecological solution. So in Deltares and also in Germany, they have developed way to use small pile caps and then this kind of reinforcement in two directions. And then they have, based on that one, they have created a new theory, let's put it in that way, where you can define this pile to do a more economical solution for the pile. This is not used in Finland yet, but I hope that in the future some of you will try to get this one, because there is a lot of research based on that one, and even in the Netherlands, where Deltares is actually, so they have been using this also for very soft peaty soils. They have a lot of peaty soils there, so this kind of solution would be an alternative for the pile raft. So that's my message.
Okay, thank you.
Yes.
So let's go on. After they introducing the pile rafts and the cap structures, let's talk about the bedding and excavating near the piles. So the bedding is usually before we install the piles, and it can provide a very stable working base for the pile installation. So the objectives of the bedding for piling work include the pile installation can be executed safely and efficiently, and the nearby structures and the equipment are recognized and removed if needed for the protection. For example, we try to minimize the vibration or the noise pollution. When we design the bedding, it's based on the strength of the subsoil and the installation equipment and method to be used. Also, for some inclined pile, we need more space for the installation. So the common materials for the bedding includes the crushed rock. This is very highly recommended materials. And some other materials require quite a thick bedding. The thickness may vary from the 200 millimeter to 1.5 meters. Normally, the most common thickness for this case, we just choose a half a meter, 0.5 meter. So in some cases, rafts made of logs or even some steel plates. Here are some special issues should be highlighted. The first one is if lightweight installation equipment is used, the side traffic should be more important when we do the design. Also, in some challenging conditions, the use of the geotextiles or the deep stabilization might be required. When we use some different equipment such as golf balls, the design of such structures must be checked.
May I interrupt here? So when once again, one of my own experiences years back, so for example in this way between Järvenpää and Lahti, so there was a peat area where we need to do piling, and then the contractor decided that instead of having this kind of padding, so then he took all the snow away and then let it froze, so you can use also freezing in this kind of way to put an environment. But I would say that it was years ago when there was at least annually one of this piling rack which fell down because there was no padding. So that's why the use of padding has improved this safety at work. But there are still some cases. I remember that last year, maybe there was at least one. Okay, please continue.
When we have finished the installation of the piles, sometimes we should do other work in construction. For example, like the excavation work. So the excavation work near already installed the piles can cause the tilting or damage of the piles. Just look like this. So when we do the excavation work, we should know exactly where the existing piles are. Often we can refer the historical design materials for help. In some sites, the excavation work near the piles is done properly, but in some cases, the know-how is weaker, and some details are missing, so it will cause damage. So here is a picture for the failures of pile. You can see it's very dangerous for the people.
Well, let me say here also a couple of words. So the piling, causes a lot of vibrations in the surrounding soil. So these failures are caused by the vibrations caused by the piling. So that's the point of these figures.
Okay, so here is an example for failures of the pile caps on the house structure. So look at this. This is the pile cap structures. They are very old and just in bad order. So this is the details for the pile cap structure. We can see the strong soil missing. So it's very dangerous for these structures. Also, some accidents in the engineering just happen due to the bad quality. For example, the footing has not been built on the piles, or the reinforcement of footing is against soil because of the corrosion, and the concrete is of bad quality, the piles are broken. So here is an example for the pile cap structure, the bad quality problems, because the concrete maybe is too soft. Here's the final questions in this lecture. Okay. So which of the following states about the bedding and excavating near piles we are introduced are correct?
The questions are still not updating here, so
Oh, sorry.
probably.
Okay. Just let's just quick look through. So the design of the bedding is based on the strength of the subsoil. Of course, it's correct. And the common materials for bedding include the crushed rock. It's correct, and it's highly recommended materials. And the excavation work cannot cause the tilting of the existing piles. Of course, it's wrong. We should be careful about the existing piles when we do the excavation work. So finally, we just gave a brief introduction for alternative method for the design of piling. Except for the manually or the hand calculation, we can use software to help us for the do the design, and it's often used in the industrial So if you are interested in it, you can choose different softwares for testing. Here is one example. It's a Geo5 software. And it's not an ad. So if you are interested, you can read some demonstration of the tutorial guide for the software.
Note that this is not according to Finnish national annexes, but
Yeah, yes,
Eurocode still, yes.
Yeah, sorry. I cannot find the situation in Finland, so I just tell them general method. So this is a tutorial video for this. So.
This tutorial shows how to design a file based on the code penetration test, or CPU. We will perform an analysis according to the Eurocode standard EN 19972. Firstly, we must check if we have proceeding in accordance with the Eurocode standard, which can be set in the settings screen. Then we load the CPGs, which are our primary input. The tests can be imported in different formats, either in the text format or other defined CPT formats, such as GIMP, CPT, or GEF. In our example, we will use the Dutch GEF format. We will select CPTs that we want to import. The calculation can be based on one or more CPTs. On the screen, we can see the distribution of cone resistance, local friction, and floor pressure. Data of both imported tests can be viewed.
So here's an example. That's all. We have finished the lecture today. Thanks for your help. Yeah.
Thank you.
Thank you.